Hello and welcome, everyone, and thank you for joining us today. I am thrilled to introduce and moderate this exciting program that we have for you, where I will be discussing strategic foresight and synthetic biology with futurist, author, and Stern's very own Professor Amy Webb. Before I introduce Amy, I'll briefly tell you just a bit about myself. My name is Mark Palatucci, and I am a senior foresight affiliate at the Future Today Institute, a foresight consultancy that Amy established roughly 15 years ago. And my specializations at FTI are in new realities and the metaverse, so combining different aspects of AR, VR, MR, XR, something called DR, as well as the futures of fashion, art, creative culture, storytelling, and strategic management. I serve as the lead coach in the Strategic Foresight MBA course at Stern, and also lead the Future Today Institute's Foresight Fellows program, which features alumni from that course. I myself graduated from Stern in 2019 with an MBA in emerging technology, and about a decade prior from NYU's Gallatin School of Individualized Study with a BA in linguistics and languages. So I have got a long history with the university, and it was at Stern that I first encountered this evening's guest. So Amy Webb is a quantitative futurist. She is the CEO of the Future Today Institute and an adjunct professor at NYU Stern, where she developed and teaches the MBA course on strategic foresight. She was honored as one of the BBC's 100 Women of 2020. Poets and Quants named her one of the most influential business school professors in the world. I know for anybody like me in the sort of MBA, wider MBA community, Poets and Quants is a mainstay. So great to get that acknowledgement there for Amy and for Stern. And she is also ranked on the Thinkers 50 list of the 50 most influential management thinkers globally. Now, to better understand Amy and her work, we have to discuss the discipline of strategic foresight, the subject Amy teaches at Stern, and a field in which she is at the epicenter. But first, I want to mention Amy's latest book, The Genesis Machine, which you can see there right behind her, which explores how the emerging technology known as synthetic biology promises to reveal how life is created and how it can be recreated, enabling scientists to really rewrite the rules of our reality. It could help us, for example, heal illnesses without the need of prescription medications, grow meat without harvesting animals, or even fuel innovations to more effectively confront our ongoing climate catastrophe at scale. Among the book's fans is Eric Schmidt, who recently tweeted that he was reading the book and found it, quote, amazing, and said he was learning about synthetic biology, which in his words, quote, will change everything. In this conversation, Amy will speak about strategic foresight and share her thoughts on the future of synthetic biology and how it will redefine the rules of life itself. Some administrative notes before we dive into the conversation. We're going to be speaking for about the first 40 minutes or so, and then we will open up the floor for questions from all of you tuning in. So please think of those questions while we're engaged in discussion, and you can share those questions using the Q&A chat feature in your interface. We are recording this session along with every reunion session, and they can be accessed immediately after each event through the same platform you're tuning in from. So Amy, first of all, welcome and thank you for being with us tonight.
Hey, Mark, it's nice to see you.
Yeah, Amy and I know each other pretty well, as will come out from this conversation, but glad to be in conversation with you here this evening. I think a good place to start is around the question of, you know, what is strategic foresight in general? And I think it's interesting to tell folks tonight a little bit about how I first connected with you in that story and how I first learned about strategic foresight. So Amy and I actually met technically over cigarettes, although it was not on a smoke break. Allow me to explain. My first semester at Stern, I took a core marketing course from Professor Adam Alter. And at the conclusion of that course, I was looking for new electives to take the following semester. And I just said, Professor Alter, you know, what class can I take that's really going to blow my mind a bit? I know that we can all take accounting and firms and markets and some of the more traditional courses, but what's a course I could take here that's going to expand my thinking and perhaps satisfy some of the more creative urges that I had within the MBA program? And he really only sent me in the direction of one person. He said, look up Amy Webb. She is a futurist, but she is the real deal. And he said, a lot of people call themselves futurists, but she is the real deal. She really does the work. So I was fascinated. And I, of course, was like, what's a futurist? A title that I now share with Amy, in which I learned can refer to many different things. Centuries ago, futurists could be members of an Italian anarcho-fascist artistic movement, which, needless to say, Amy and I do not belong to nowadays. But more specifically within the field of futurism, strategic foresight was the field that I wanted to study. And so I took Amy's course. The thing that differentiates strategic foresight from other areas of futurism or modern futurism, which sort of encompass a lot of different areas in which folks and organizations are looking to sort of analyze and mitigate the uncertainty of the future. What sets strategic foresight apart is that there is a rigorous methodology that can be applied to the information we have at our disposal today, and helps us model the future, not predict the future, but model the future in a way that is immensely valuable to organizations and individuals. And so in Amy's course, we, at that time, we all were choosing sort of a stand-in client for whom to work on behalf of and apply the futurist methodology. And my group chose Philip Morris, hence the cigarette comment. So we were looking at the future of smoking. Amy, I wonder if we could start by just you describing a little bit about what the FTI methodology entails, and maybe you could use that project, for example, as a topic, as how we applied some of those frameworks and pieces of the methodology.
Yeah, so thanks for the introduction. And as I was listening to you talk about that project, I guess it was 2019, but I swear to God, it feels like it was ages. That's only been a few years.
Yeah.
It blows my mind. So the class that I teach, but Mark also teaches with me at NYU, really goes through all the different steps of our Foresight methodology. And for some of you might have taken that class because there are recent grads who are with us. I was trying to remember, I think I came to NYU in 2016-ish. I was at Columbia teaching before that. But this course has been designed to hit the high points of Foresight. Foresight sort of sits adjacently to strategy. So strategy, is looking narrowly in a good way. It's going out a few years, but there need to be concrete tactical actions as a result. The work that we do sits adjacently to that, but we are doing data-driven modeling. We're doing pretty serious research, but it goes beyond. And the purpose of our work is to explore what's recently plausible. And the point of that is to sort of push ourselves to take in way more information than we normally would across a very broad array of signals and forces of change. Paradoxically, we go wide so that we can help reduce uncertainty, so that those who make decisions can make sound decisions. It's this process that we teach that helps companies, helps people see around corners. So as Mark said, we will be the first people to tell you there is no way to predict the future unless you've got a real narrow data set. But what you can do is explore plausible alternative futures, which is really important. Now, the plausible future that Mark's group was exploring was what's the future of smoking, but specifically juuling, right, Mark?
Yeah, we got very quickly into the Juul was especially popular at that moment. And so we were thinking, how's this all going to play out? There were interesting sort of changing sentiments amongst especially young people around smoking. And so it was a ripe topic at that time.
Yeah. What was pretty amazing about this group is that they went forward in time and said, given what we know to be true today, consumers seem to really like this product, which at that point hadn't hit its plateau. People seem to be on this there seemed to be this adoption curve. But at the same time, you guys were looking at, this is heavily unregulated. There are other forces working potentially against this. Anyhow, you both sort of saw the upward swing and eventual demise. of Jewel. And it was so like, this is why I teach. And I think probably, Mark, this is why you keep coming back for more. It's because it's really amazing to see people get the point of foresight and see the value of strategic foresight. But to see them work on really interesting projects. And in the time since then, the class is now using live case studies. Am I too far ahead in our conversation, Mark?
No, please,
okay.
Go ahead.
So we're doing live case studies. So rather than sort of students picking companies they want to explore, we've brought companies to Stern. So this semester, Mark is in charge of roping and managing and wrangling the companies. We've got 8.
That's right.
And they range, this is not the first time we've done it. It's the first time we've done it sort of while class has been, I was going to say mostly not remote, but we're a little bit remote now. Anyway, so we've got, we've got really interesting projects that run the gamut from news products, future of news products and distribution, to the future of reducing plastic for a medical supplier. The projects are pretty amazing. Anyhow, we're talking a lot about this, but here's how the class ties into the outside world. So you left class, you joined us, and then you quickly dove in head first into H&M.
Absolutely. So yeah, just to give a little bit of a sense of how what I learned in class applies in the real world and to real world organizations. And that, this is the work that FTI does. And so we sort of begin teaching it to the students so that they get a handle on what this looks like, what some of the tools are. And then even in this sort of like case study format, give them the opportunity to apply them in sort of a somewhat lower stakes environment. Once I came on with FTI, I was thrilled to be able to work with H&M because I have a background in design, fashion. It was an area that interested me. And this was a company at an interesting sort of juncture and inflection point in their trajectory, because they had long been known as, high volume producers of clothing, multinational, really global footprint, both for better and for worse. And they were looking for potential solutions, especially around improving their impact on the environment. And so a big part of Foresight is creating these futures. I didn't mention it earlier, but when we talk about the future, it's actually kind of a misnomer for a practitioner of strategic foresight, because we see tomorrow as a range of futures. And part of our job is not predicting one empirical future, but the different probabilities of different sort of narratives playing out. And so we build scenarios that sort of illustrate those different probabilities, and then help organizations prepare for those that are most probable, and see where they can fit in the sort of most preferred way for that organization, so that they're the best prepared. And working with H&M, especially with my specialization in sort of metaverse and new realities, it was fascinating to be able to build a future with them and for them, in which we could envision what we sort of started calling the hybrid wardrobe. So we were taking from other industries and other businesses, which we often do in Foresight, to take some learnings and apply them to fashion. I thought of how when you buy a vinyl record nowadays, which is an old school kind of tangible product, it comes with a slip that gives you access to lossless audio files, which are sort of the most modern version of that same product. And we thought, could we apply something like this to fashion and create a virtual wardrobe where when you buy a garment, you're also getting a virtual garment that you could wear in virtual and metaverse realms, but maybe it also tracks that physical garment, so you get a better sense of the life cycle of that garment and getting more data on that product. And so exploring, sort of narratives like this and making them real for the client was a really satisfying experience and a great opportunity to see Foresight in action in the wild.
And I would just add that sorry. I was going to add, I think what's important here is that this seems like, well, yeah, fashion companies are all talking about the metaverse now, and they're all talking about digital fashion, but they weren't at the beginning of that project. The other thing that we pushed them to do was to, where could we unlock growth in different ways? One thing that we introduced, 2 things we introduced. One had to do with AI and predictive modeling to determine who's going to want what when. And that was that was different. But the other sort of crazy thing that we pushed them into, because we had their trust, was, what if you engineer your materials? What if you create clothing? There was who was the celebrity that actually like talked about this, and then it turned out to be a joke? Mark,
I'm blanking on it, but
she's the one who had all the plastic surgery in one day. Blonde. Anyhow, we recommend, like, one of the things we said was, what if this was like hyper fast fashion, and the clothing was really only intended to be worn one time or even two times, and then after you wear it, you compost it. This was like crazy sounding, but the net result of that type of technology, which exists, reduces carbon footprints. It drastically shrinks the global supply chain. It's potentially better. It's definitely better for the environment. It's all of these things, and all of these things fit under the umbrella of something called synthetic biology, with a sort of adjacent foray into artificial intelligence. Very few, I don't think any companies, none of their competitors were like, how we grow in the future. We grow we grow using organically produced cells that we've created that we can turn into fabric. Like, nobody's thinking about that. And to be fair, this is longer term, higher impact, bigger bet strategy. But this is all of the companies that you think of as being the most forward thinking, the most future prepared, the ones that are disrupting the market ahead of everybody else. That's what those companies are doing. They're thinking near and long term simultaneously. And it can be done. You just have to have the discipline and the organizational culture to support that. So that was just the project lasted a year, and we started in one place, and they, over the course of a year, allowed Mark and the team that he was leading to go into all of these crazy different directions, which are producing tangible results, which is cool.
Absolutely. And Amy, do you want to spend just a minute talking about another great client who, one of our earliest clients when I came on, was in the ice cream space. And I sort of thought to myself, well, this is great, but also innovation in ice cream, I don't know where you can work in technology. Sure, maybe in the supply chain, maybe here and there, but there were some interesting conclusions we came to around synthetic biology as well in that space. I thought you might touch on that for a moment.
Yeah, and to be fair, we're not supposed to talk about all of our clients. I detail all of the stuff we worked on. Most of the organizations that we work with are Fortune, I would say, 100s. They tend to be global. They tend to have interesting challenges, and we span most industries, I think, at this point. This particular client was interested in two things. So they actually wanted to build a Foresight team. And that's something Mark and I are hearing much more these days. A lot of companies are putting together, like, they've either hired on a futurist, somebody to be in charge of Foresight, who's very excited, and then probably gets inside the organization and is like, because it's not a one-person job. It takes a team. And there are companies setting up these teams, Foresight teams, to do exactly what we're talking about. And so the company that owns Haagen-Dazs, which is General Mills, was trying to do that, right? They wanted to set up and sort of codify a system for Foresight, and they've got brilliant people on that team, and they just needed a process and a methodology, and we used a sort of live case study approach, which was ice cream, to help them both learn how to do it and then get to some reasonable outcomes. And we wound up with 3 huge work streams out of that. But again, one of the questions that we asked them was, what if ice cream didn't involve cows? And what if the best ingredients in the entire world, the freshest, best ingredients, weren't grown outside on a farm? They were grown, indoors, in different circumstances. And what if molecularly the cells, the stuff that the proteins that produced the dairy part, the milk, and the Molecularly, the other ingredients were identical. The vanillin, was identical. Wasn't synthetic using like synthetic chemicals, just processed and developed in a different way. Wouldn't that be still very natural and very organic, and in a way potentially better? And it just, again, like, these are longer term, bigger bets, but it unlocks optionality that just didn't exist before then.
Absolutely. So a big part of working with our clients is the research that we do around emerging technologies, and we have as one of our core topics tonight, synthetic biology. We've already discussed how it can touch different industries, from fashion to food and beverage, to many, many more. But I want to make sure that our audience tonight, Amy, gets a good sense of what exactly synthetic biology is and how it differs from some things we may have heard of already. I think just a month or two ago, there was a news piece around a patient who unfortunately passed, but who had received a pig heart transplant, and that pig heart was altered genetically with using CRISPR-Cas9, and a powerful sort of biotech tool. But that wasn't quite synthetic biology, was it? I mean, how does synthetic biology differ from the gene editing that we've sort of been hearing about for some time now?
Right. So, and that is the topic of my new book,
Yes.
which is here, which is the Genesis machine. So we've mentioned this a couple of times. I think what's important to note is that we're just living through a very, very interesting time in human evolution and the development of our culture and our society. So we all talk about AI a lot, and we should be doing that because that is certainly changing things. There is and that's, so we all cover different research areas at FTI. Mark is all things metaverse and digital luxury fashion, all the stuff he talked about. Mine is AI and this sort of new area of science called synthetic biology. And broadly speaking, synthetic biology is an emerging area of science, relatively new, like 10, 15 years old, that involves redesigning or designing organisms to have new, augmented, potentially different types of abilities. And it's an interdisciplinary field born from AI, people who are computer scientists, people who are engineers, who are also interested in biology. If you think about our bodies are full of trillions of cells that each operate like its own like gigafactory, its own little factory that's making decisions, doing things all day long, over which we don't really have control. Nobody stops and thinks, right now, gosh, hey, I'm going to need some cells to divide because I'm going to need those cells later on. Like we're not conscious of what's happening. In a way, we are walking, talking, squishy robots. We humans are just containers for code. I don't mean to sound nihilistic, but that's kind of what we are. And if you're able to practice reperception and to think of biology a little differently, biology as a function of code, that unlocks new pathways, new ways to think about, well, how do we read that code? How do we edit that code? Potentially someday, how do we write that code? Or can we write that code now? This is analogous to computers, right? So right now, or actually in the 50s, Watson, James Watson and Crick, it was mostly Watson, totally ripped off a female colleague's work and gave her no credit for it and actually chastised her on the side. So that person is Rosalind Franklin. That's the name that you should know. That gave us the ability to see biological code, DNA. And after that, increasingly, we were able to read it using new techniques. With some more progress, we were able to edit. So Mark, when you're talking about CRISPR-Cas9, that's sort of another way to think of this as molecular scissors, allowing us to cut and paste the way that you might cut and paste on a Word document. Well, recently, we've been able to harness new permissions We actually have write level permissions to life, meaning that if you've got something that kind of looks like an old school SQL database combined with an Excel spreadsheet, if you have sort of base code, which instead of ones and zeros, computer stuff, is ACTG, biological stuff, and you've got sequences and you know what to do with them, you can start combining and moving them around in different ways. And once you have the sequence that you like, you can synthesize it by sending it, and I'm not making this up, to basically like a 3D printer. I was just at a conference last week. I don't have one of these in my house, but it's about like this big. You know, it looks like a print. I mean, it looks like a printer. And you send your code, and you have to have reagents and, you know, other things there, but it basically prints out new molecules. So that's not science fiction. That is present day science. And this is really important because I know immediately people think about, well, does this mean we're going to be printing new people? Are we going to print hearts, for example? That's pretty complex. We're far away from that. What is present day reality is that, you know, we don't have to rely on the far western regions of China, which are fraught, as we all know, for cotton. And that's where a lot of cotton comes from. We can manufacture synthetic versions of that, which are based in the real molecular structure that exists, just in different ways. The Super Bowl, which Mark and I were glued to the televisions for. Maybe you were. I don't know. You're not like a football person.
I had it on in the background.
Okay. I was watching. We were fast forwarding the game to get to the commercials. You know, Americans ate 1.45 billion chicken wings on a single day for the Super Bowl. It required 750 million chickens, billion chickens, million chickens. Anyhow, that type of cultivation is really damaging to the environment. You need chickens that are pumped full of hormones and antibiotics. It takes a lot of feed. And while these chickens may technically be free range, right, meaning they're not in horrible cages, they are in a giant warehouse shoved together. It's not like they have anywhere to range to. So the question is, you know, just what if there was a different way to do that? And the answer is there is. You can take a bioreactor, which is kind of like a really big pressure cooker. You get stem cells, muscle cells from not today's hormone infused chickens, but let's say a heritage line of organic chickens. You mix in amino acids, which would have been present anyways as they were growing. You control the circumstances so that you don't need the hormones, you don't need the antibiotics, and you have chicken meat within, you know, a relatively short amount of time that didn't cause environmental problems. You know, it's better for us because they're not pumped full of all this extra stuff. I mean, hell, it's better for the chicken, right? And this is being done, and it's already passed regulatory approval in Singapore. It took 2 years, but there are now, you know, chicken meat that went on sale for like $17 a portion. My point is, this technology changes everything. And what you need to know, and the reason that I wrote the book, is that we can now program biological systems the way that we program computers. If you stop and think for a moment what that actually means, it is profound. And we're on a very long, this is a long horizon tech, just like AI. But my concern is if we don't have a public dialogue about this now, including things like, hey, here's a whole bunch of business opportunities, you know, and here's how all of this stuff really helps, then we wind up with significant problems down the road that range from IP challenges to, you know, government regulation coming out of nowhere, and also weaponization, which we don't want. That was a very long answer to your question. I didn't answer the question about the heart.
It was.
The heart is the heart. So SynBio is kind of like an umbrella term, like AI. CRISPR-Cas9 is sort of, I would say, in that umbrella. The process that was used to grow the heart inside the pig, I would say, is in that too. And listen, it's great that we can do that. Pigs are very closely related to us. But I would also love to see a future in which we don't need to grow animals and harvest them for their, for their organs. Mm-hmm. By the way, a lot of people don't know this. That's where insulin started. So insulin, in the early 1920s, there was a Canadian guy named Charles, Bantam and Best, these two guys, figured out that they could secrete the pancreases, I think of dogs to start off, and through a kind of a gruesome process that involved pulverizing dog tissue, they could secrete insulin and purify it and inject it into humans who were suffering from diabetes, which at that point they didn't have a cure for. And it worked. The problem was these guys were like going around and collecting stray dogs, and like, that was not great. And then they realized, well, you could use, other types of, you could use cows, right? The problem is that, so anyhow, I'm off track, but we've been using animals for a long time, for medicine, for therapeutics, et cetera.
Mm-hmm. I think what I like about, obviously you answered my question and then some, but the core kind of takeaway for me, especially the first few times learning about synthetic bio, is that if we've been gene editors in the past, this makes us more gene authors, in a certain sense, and so it just expands the repertoire of what we can do with that science. You spoke briefly on this, but the technology in some form or another has been around for a decade plus. It has inspired you at this moment in time to write this book, right? To capture the information that we have and to capture, in some ways, this moment that we're at in the trajectory of that technology. Why now? You spoke again briefly to it and wanting to start that dialogue, but what is unique about this point in history?
So I would say there are a couple of things. The first has to do with money. So the messenger RNA vaccines that most of us have now taken were in development well before COVID. They were in development for something else. So a lot of the companies working on them were working on cancer therapeutics, just new ways to engineer instructions to deliver to our bodies. And this is one of these like weird areas of science, and it just was taking a long time to get through regulation, like regulatory approvals and things like that. COVID, somewhat ironically, because it was so damaging to so many people, we will probably look back on as a breakthrough moment that ushered in entirely new forms of medicine. And sort of paradoxically, as awful as COVID has been, and as many of, I've lost people, we've all lost people, we may look back on this time as this sort of breakthrough moment, the unfortunate catalyst we needed to push some of these initiatives forward. So there's been a flood of investment. So SARS-CoV-2, which is the virus that causes COVID-19, all of the research, the sequencing, the synthesis, all of that stuff, it just became this catalyst for funding, from individual investors all the way up to governments. And so that sort of started the ball rolling. The efficacy of messenger RNA fueled lots of new interest from people saying, well, what else could we be doing? There's all different types of biotech. What happens if we reprogrammed the body in different ways? There's some biotech veterans that raised $3 billion in the past couple of months, billion with a B, to found something called Altos Labs, on the premise that the fundamental machinery of life can be reprogrammed, right? Cells can be reprogrammed. They don't have a product. So this is $3 billion on an idea and some talent. So what is the valuation on that? Like, who papered that? What does that even look like? I cannot grok that, right? But the fact that there's this money now coming in, there was a pretty huge McKinsey report that came out sometime last year, I think, talking about the size, its projection for the size of the overall industry, and they're projecting $4 trillion sometime, relatively soon. So there's this flood of capital that's being directed, and basically what that tends to mean is that it floods the ecosystem with new startups, most of which won't survive. It creates new research opportunities. It creates, a hype cycle. This is going to have downstream impacts on a ton of different industries, on pharmaceuticals for sure, and healthcare, but also, some of the stuff you heard Mark just talking about. So retail companies, industrial materials, space. And when we tend to see these cycles happen, that catalyzes innovation. And my assumption is that everybody who's here, all of our alum who are probably now working in different areas of business, you haven't yet heard about synthetic biology. You may never hear those words spoken, but what we're talking about tonight changes. It impacts everybody's industry in some way. So that's partially why, because we're now on this faster, accelerated track, which is good. But the other concern that I have is, if we look at what happened with AI in the 80s, what leading up to the 80s, in 1956, John McCarthy, Michael Mins, come on, Amy, my brain is totally melted. Marvin Minsky, geez. They hosted this summer workshop at Dartmouth, and it was at that workshop where the term artificial intelligence was coined. They had a bunch of, all men. They had a bunch of people together, different walks of life, all trying to imagine. They were building on some of Turing's work from earlier, but what would it take to make a computer think and to make automated decisions? At any rate, they come out of that filled with crazy ideas. They all go back to their individual labs. They start working on things, but the idea takes hold. Mm-hmm. And it takes hold in science fiction, popular fiction. They're interviewed on television shows. Eventually they're on Life. And these huge promises are made, including to the United States government about simultaneous translation between, English and Russian. None of these things were possible at that point. A computer was literally the size of the room that I'm standing in. So these outsized expectations, when they didn't come to fruition, wound up causing what's known as the AI winter. Funding dried up, programs dried up, et cetera, et cetera. So part of the impetus for the book right now is there's all this investment, all this excitement, which means we're going to see innovation cycles. We're going to see the ecosystem develop. So we want people to be paying attention, but I also want people to take a giant chill pill because this is long horizon stuff. So that's the first reason. The other reason has to do with risk. Generally speaking, regulatory frameworks are totally outdated. We have massive problems with IP and who can own IP to living organisms or the genetic code of things. And, we also have some unresolved issues, especially in this country, about how we think about life itself. We're not going to resolve these challenging issues overnight. It's going to take time. And so my hope is that the technology is now on an accelerated path because of the funding and the early success stories. The societal implications, how we think about these things, how we talk about these things, getting our regulators interested enough to pay attention, not suggesting they regulate at this point, but I want those paths to be in parallel, because if they're not, how many times are we going to see the same story over and over again? There's this huge tech development. Everybody suddenly now is very upset about it, and it causes massive problems. That's an avoidable problem. It's an avoidable situation right now, but we have to be more grounded. So there you go.
Awesome. I mean, I think you have spoken of a few points tonight about how this is a long horizon technology. So there is, sometimes it can be hard to think about an abstract future or a future that seems abstract at the moment, and to bring that to life to an executive who may spend their their everyday workday thinking about maybe the next quarter, perhaps the next few years, but we're trying to push the perspective out into 5, 10, 15-year time horizons and beyond. One of the ways we do that is through scenarios, which I mentioned before. And your book, I wish we had a bit longer tonight to talk about some of the scenarios that you've generated for the book, but just for our audience's sake, there are some fascinating, essentially they're like, immersive narratives. So they really put you in that future. And some of the ones that you generated for the book included not just synthetic biology's effect on the earliest stages of life and how we potentially can sort of tweak and modify our own offspring, but also even the latest stages of life and how we might use synthetic biology to mitigate some of the effects of aging. Another of the scenarios I think is a really interesting illustration of the fact that in the past we've always envisioned the future of humanity as sort of an upward trajectory. I can see skyscrapers in Manhattan out my window right now, right? We've always looked to build upwards and outwards and potentially go off planet. But you sort of describe this very robust and immersive future in which potentially synthetic biology can facilitate building from the ground down instead of the ground up, and developing communities and economies and infrastructure beneath the surface of the planet. So just wanted to give a quick shout out to those. If folks want to read those in greater depth, obviously, they'll have to grab the book. Before we switch to questions from the audience, which I definitely want to leave some time for, I wonder if you could give sort of a brief bit of advice to those CEOs and businesses. And again, I'm sure plenty of our alumni on the call today who work within these businesses that are seeking to learn more about synthetic biology and prepare for a future in which there really is a dawn of this technology where it becomes more pervasive. Yeah.
So again, Mark and I will always be the first to tell you, we're never going to tell you the date. Everybody wants to know when. Our answer is soon. We can give you a range. So I can't tell you exactly when the next huge inflection point is. What I can tell you is that synthetic biology, the name may change. It's a terrible name. The way that this is being talked about today will very likely change. But the core technologies, again, this is about using computers to influence biology, cells, tissue, right? Giving us control over what that looks like and how it evolves. There is not a single field that doesn't influence. That influences people who are in financial planning, because as Mark alluded to, one of the scenarios in this book asks the question, what would it be like if everybody gets older, but never really gets old? And if we are living ultra long lifespans, is that going to be accessible to everybody? If it is accessible to everybody, how does that not totally upend? That would drastically influence what the future of work looks like. If you're a family-owned business, what does succession planning look like at that point? If you're a sports fan, what happens if listen, I'm a big baseball fan, and there are some players that I love who probably should not still be playing. What happens if they never retire? What happens if our politicians stay in office, because we don't have term limits? What does this do for social safety nets? I could literally go through, and that is just financial planning. That's it. So how does this break a financial planning model? I could have a similar conversation about insurance and how does this break actuarial tables while also potentially unlocking opportunities. Agriculture, transportation, covers every single field, because what we're talking about is gaining access to engineer the future in a completely different way. So the advice that I would give to CEOs is, now is the time to at least get your head around the lexicon. This book was written, it's a book about science, but it is very much not a science book. This was not written for the community working in the field. This is written for everybody else. It's important that you get a handle on what this is now, because I have a feeling that 10 years from now, we will look back on this moment in time. 10 years from now, we'll be talking about synthetic biology the way that we talk about AI today, which is to say, a lot of people have opinions, most of which are very uninformed. And routinely, I run into senior level executives who are forced into making decisions about these things without having enough knowledge. So now is the time to get prepared. So that's what I would say. Mm-hmm. Obviously, read the book. It's called The Genesis Machine. But there are different communities you can plug yourself into. There's one called Built with Biology, which is an online community. John Cumbers posts a lot. He's a former NASA scientist who works in the space and publishes a ton of content. Khan Academy has, accessible classes on this. So there's lots of different touch points. At the moment, it's all you need to do is just be aware and be open to new signals, new data coming in.
Mm-hmm. Mm-hmm. All right. So in summary, educate yourself, read the book. I also would add something that we're often saying to our clients and to our students: don't ask the question, could this affect my business? Ask, how could this affect my business? Mm-hmm. Because with a technology like synthetic biology, in all likelihood, it will disrupt some aspect of your business model or your organization. Thank you for that, Amy. I think we'll turn to some questions from the audience. So thank you to those audience members who have submitted. The first one I have is this. It sounds like there can be some great impacts on sustainability branching out of synthetic biology. But do you see SynBio having potential negative effects on sustainability in certain industries?
Yeah, so that's a great question. COP26 ended last year without the great kumbaya moment that I guess people thought was going to happen. We've got two enormous economies, India and China, who at the moment do still rely on systems and processes that produce CO2. That is current day. You can't tell those companies to shut that off immediately or within the amount of time that we need. Although we would love for that to happen, there is no alternative in a lot of places, around those vast countries. So, it is, unfortunately, we've waited too long to make a decision. And yeah, we need to do something about CO2. So again, this is an opportunity to practice reperception. What if we looked at CO2 as a feedstock? Because that's actually what it is. We just have too much, right? We've got an abundance of it. So what if there was a plant that was engineered to suck more CO2 out of the air and, convert it and hold it and eventually, excrete, some type of a product, a byproduct that would be good for topsoil, right? So there's actually research already underway on that at several different universities. It's just a different approach. And from my vantage point, why would we keep coming back over and over again to the table, forcing everybody to do what we know they're not going to do? Why not instead harness the considerable brain power that exists around the world and say, let's come up with, 20 viable ways to harness this technology. And let's see if together that constellation of activity actually makes a pretty big dent. My hunch is that that's a better, faster, more reasonable solution than waiting for all of the governments around the world to align. So that's an opportunity. Now, there would potentially be downstream impacts, as there always are. A downstream potential negative impact is maybe countries that create fertilizer right now, aren't creating fertilizer anymore. Maybe we don't need fertilizer because we can use feedstock. CO2 is a feedstock in different types of plants. So there would certainly be some type of impact. But again, this is what Mark and I do, right? The scenarios in the book are intended to allow your mind to wander productively. But most of the time, these scenarios are strategic. We're trying to map out if this, then that, right? What might happen? So as long as you do that in advance and you plan for it, then it's an addressable issue.
Mm-hmm. Now, I've got a couple of questions here about inclusivity and access to this technology. So one audience member asks, how can distributors of this tech make sure it's accessible and affordable to those who need it most? And another asks, do you foresee profit-motivated competition in SynBio, or do you think scientists might have the ability to work more collaboratively to provide aid to the general public?
Those are very good questions. So let me start with the second one. It depends on where you are. The scientific community is collaborative, but they're also, they work behind closed doors. And in the United States specifically, there's money to be made. So the problem comes with patents and licensing. Some of you probably followed the legal issues. Berkeley, so researchers at Berkeley and researchers at Harvard and MIT, they have a joint institute. They had worked together. Scientists all read each other's papers. They're all feeding off of each other. At around the same time, they both had cracked the CRISPR-Cas9 code. They both filed for IP to the USPTO for patents. And the question was who got there first, and there was a lot at stake. Whoever gets there first gets the patent, and whoever has the patent has the ability to license it out. That's where the money comes from. So there's, we have created competition, because of these structures that were never designed to cover biology. They were designed to cover widgets. Like the patent office wasn't, when it was first founded, they weren't thinking about, well, maybe in the future, like we'll be able to engineer tissue, living organisms. And there's an argument to be made, should somebody be able to patent a living organism? At any rate, so originally the patents were given to Jennifer Doudna and her partner. So she's at Berkeley and the partner was at a different school. Huge, big deal. They go on to win the Nobel. Well, just a few months ago, the USPTO reversed its decision and has now awarded the patents instead to the other person, Feng Zhang, who's at a for-profit university. This has enormous implications. If you were a research scientist that had gotten the licenses from the Berkeley people, you now have you've got to figure out a way to get the licenses from the other people. So there's red tape, there's bureaucracy, there's incredible expense, we should ask ourselves if this is the best way to foster innovation. I don't think it is. I think this is terrible. So that was the second question. At the moment, we've set up competitive structures, and it's fine. We want to encourage competition because it pushes innovation forward. But we also want to be very mindful about what we're creating and for whom and why. And that goes to the first part of the question, which is inclusivity. Listen, all we have to do is look at who got COVID vaccinations first. We in the United States had vaccines. There were plenty of emerging markets around the world that didn't. And it was, unforgivable how long it took to distribute and make equitable those vaccines. And it wasn't a supply chain problem. Some of it was a licensing and funding problem. So we need to really think this through, because on a global scale, biology tends to self-sustain. And so we need to be making decisions for the future of the public good to the extent that we possibly can. And we also have to make sure that the developments that are created are intended for everybody. There have been some instances that have been widely reported. The doctor researcher in China that He Jiankui, who worked on the now we know babies who were edited, their embryos were edited using CRISPR. There's not a ton of data. Did that actually happen? He says it did. What was actually edited? Things are a little murky. What's really, really murky, though, was whether there was informed consent and whether or not the people who supposedly volunteered and signed up to be a part of this experiment knew what they were actually doing and what the implications were. We don't want to be in a situation where people who are ill-informed or in economic circumstances that are not ideal are guinea pigs, So again, this is just, we've been here before in many different areas of science and tech. It's time for us to buckle down and plan. This is simply a matter of thinking things through, thinking about next order impacts, being planful, while also being flexible and being willing to continually confront our cherished beliefs and recalibrate when necessary.
Well put. Let's turn to this next question, which is, certainly one that interests me, which is, how might the metaverse play into all of this? Do we see there being any potential? Yeah, any potential sort of interplay? I think there inevitably, may be some interplay between SynBio and the metaverse. How do you imagine that might look?
Well, I think maybe from an experiment point of view, like so DeepMind, which is part of Google, has something called Mu0. And they're working on all these interesting AI projects and protein folding projects. And those, I believe, render in sort of an XR style environment. I think making some of this more tangible, as for researchers, is going to make it easier, faster, more compelling to do that part of their job. And then probably things like digital twins. If it's the case that one of the things I know to be true is agriculture is going to change. It hasn't changed in between 10 to 14,000 years, depending on who you talk to. We now have optionality. So if we've got extreme weather events that we can count on, right? Because there's too much energy in the atmosphere. We've got geopolitical tensions, all these things. What does that tell us? Our global food supply is in peril to some degree. What if we brought all that indoors? We created different conditions and made it easier. We would have to edit plants, but we made it easier for them to grow in different circumstances. To get to that point, you need the science, but you would also need a digital twin to be able to test out those conditions in advance and sort of, see what might happen. I mean, does that sound, this is the area that you've got expertise in?
Sure. Well, yeah. And when I saw this question, I was like, I'm going to ask it, but I also know, knowing Amy, she may say, well, what do you think? And I think the first place that my mind went was also around, I'm very interested in, we're already tackling a lot of the audiovisual elements of the metaverse and immersive realities. But olfactory science is very interesting to me.
Oh, yeah.
And how we're going to generate tastes and smells, because there are just so many variables. And we really want to recreate seemingly organic or natural elements and stimuli in that space. And so that was something where I thought synthetic biology could be helpful, especially at scale. Yeah, go ahead.
Talk about the scent collar that you showed me, this crazy
thing.
It's
true. We did a newsletter through FTI recently where in an attempt to create some hardware that can add olfactory elements to a metaverse experience, a VR experience, there are companies developing devices such as a scent collar, which sits around your neck and essentially puffs an aroma up into your sensory organs here, that is synced up with elements in your virtual surroundings to create a more sensorially immersive experience. So definitely some pretty crazy stuff going on in that space. And definitely, I think SynBio will come to play more and more, as we look forward. Amy, before I sort of close things out for the night, I just wanted to see if you have any final notes for the audience, and also if you can just tell them where they can find your book.
Yeah. Well, the easy question is where to find the book. The book is available basically everywhere books are sold. I always ask people to support their local bookshops. So if you've got a local bookstore near you, I'm sure they would love your business. But there's also a website called bookshop.org, which you can purchase the book through, and then they'll actually order it from a local business. There's also Amazon, things like that.
Naturally.
I don't know. I think the last thing that I would just like to say is I started teaching this class because I'm very worried about the future, but I'm hopeful we can do something about it. I'm worried that businesses are increasingly thinking shorter and shorter and shorter term. They're not doing strategic planning because they don't feel like they can in this VUCA world, this world full of volatility, uncertainty, complexity, and ambiguity. They're just not doing it. I am here to tell you that even when it becomes very volatile and complex, you really have to do the planning. It is something that can be done. This is not intuition. It's not gut checking. It's not reading a bunch of Wall Street Journal articles. It takes work and discipline, but that's why I teach the class. And that's why it's delightful meeting people like Mark who get it and see it and and wants to do the same thing. So we are not making money teaching this class, which is pretty intense. We are doing it because we believe in the value of foresight, and we want to show other people how to do it because we want them to do it. We need them to do it. I need you to open up your mind to alternative futures and to continually seek out new information and to be flexible. I need it. Mark needs it. Our future demands it. So that's what I would leave everybody with.
Great. I think that's a great note to end on. And on behalf of Stern and NYU, I just want to thank you again, Amy, for joining us today. Also want to thank all of our Stern alumni who were able to join this evening, and for your support of this program and the reunion program in general. I encourage you all to stay engaged with the Stern community and to join alumni groups on Stern Network so you don't miss out on any of the upcoming Stern alumni events. There were a couple more questions about foresight and learning more about how to create a foresight capacity within organizations. And I would just guide you to the FTI website at futuretodayinstitute.com. We have a free trends report that we put out there, and there's plenty more resources. And we encourage you to hit the contact button on the site as well and reach out to us directly if you so choose. So thank you again for being with us tonight, and everybody have a wonderful evening.